Okay, now I want to show you some application. All of them are from the standard multi-center. I'll start with the first application. So in this case, like I said, the machine is a standard machine, but we're studying a fixture to allow the customer to machine four-way components. Now I'm going to show you what I mean by four-way. So the fixture itself has a bridge for locking down the part, and by turning the B-axis, you have access 360 degrees all around the component. So in this way, you don't have to do a second clamping, and this gives you a lot of flexibility. Now I'll show you. You can see how you can program the B-axis all around and have access. Now, in this case, we have a component with 90 degrees between one end to another end, but any angles, you can reach it because of this fixed bridge around. So this is something nice that gives you some flexibility if you have this type of components. Another application is to show how fast we go from setting up one component to a different component. Because the key, like we said before, is to produce only medium low quantity. Don't build any stock in your company, but just produce what you sell. Thanks to the big enlarged magazine, you leave all the tools of your different products in the tool magazine, and you concentrate only to change the clamping fixture. So here we studied a system that are based on the lean manufacturing concept, where the operator really is going to change with a screwdriver, just making a lever, taking out the top jaws, and doing the same operation on the bottom, taking out the bottom one. Now it's going to take the new jaws and just snap on the lower one and snap on the top one. And you see in 20 seconds, you can see how quickly he changed. I'm going to show you one more time. So here again, just make a lever, take out the first jaws, the second. Now you have another set ready with the second part. Snap on the new part and snap on the top part. So these 20 seconds you have to multiply by the number of stations, which in this case are 4 stations. But even if you think about a minute per station, in 4 or 5 minutes, depending on the speed of the operator itself, but in 4 or 5 minutes you can change over from one part to another one. Because then it's just a matter of taking the part program, selecting your next job, and tools are already in the magazine. So it's really fast. This is a different concept, but with always the same target, changing fast from, this is a 5-spindle machine to a customer that chooses to have 40 tools per spindle, so we have 200 tools in the machine, because he has about 80 parts to be run through this machine, but the changeover must be really fast because he doesn't want to do any stock, any inventory, so he just really wants to produce what he sells. So here we develop a system with all the tools in the magazine, and now shortly you're going to see how we're going to change station. So this is the previous job. It's going to change with a different job, which is over here. So you just put a tube, press to unlock the fixture, taking out the old job. Now it's going to take a different part, put it back in, and then it's clamping again. And you see how in 30 seconds he changed over the station, and again, this needs to be multiplied by the number of stations. And then here the process starts. Now I want to show you this application, which is a feature that is having a lot of success to machine complicated parts and avoid the reclamping operation. As you can see, there is holes, angles, different way. This is a feature that allows you to machine a component in 5 sides. So it's a self-centering chuck. It's 20 millimeter per jaws. Here is the load and load station, so it's hydraulically clamped. Now we have in horizontal spindle, you can machine all around, but you cannot machine the top and the bottom. So in order to do this fixture has the capability of indexing 0.90. So your top operations now goes horizontal, and now you will, with your B-axis, you can again reorient it and machine it. I'm going to jump this part and show you directly what's happening in the machine when it's in automatic. So in each station with an M code, you can program horizontal or vertical in each station. So in essence, it's like that you are deciding if you're having a horizontal spindle or a vertical spindle in each station. So this feature makes the machine even more flexible. The next application is something similar, but instead to have a self-centering hydraulic chuck as a real fixture with hydraulic clamps, as you can see, opening and closing, but has the same system of 0.90. So this part has 5-side machining. And you can machine all of them in one clamping, which allows you to reach tremendous precision between the machining, instead to do operation 10 and operation 20, which always lose something, talking about tolerances, because in this part we have a lot of CP and CPK value. Was a really nice application. So we clamp one, we machine index 0.90, and once it's unclamped, part is finished. So this gives, again, more flexibility. In this case, we have an interesting application where there is a bar feeder with stainless steel bars. So we cut the part, there's a robot loading and unloading into the machine. All the movements are CNC because the operator only select from one panel which part he needs to machine, and the cutting, the saw, the machine, the robot, the marking device, everything is automatically aligned to the part to produce. So there is no operator involved on setting up the saw machine, setting up the machines, setting up the robots, the marking, because again, our systems that are studied to produce medium low quantity, and we want to take the less time possible during setup. In here, so you have the robot taking the part from the saw, loading into the machine. Here we are producing 2 parts, 2 identical parts. So every time the table index, you have 2 finished parts in this case. So the operation starts with, the standard operation like drilling, milling. So the bar is clamping outside, so we can machine all the inside. But this part needs to be machined also the outside where we clamp. So at one point, once we are done with all the internal machining, on the last station we have on the tool magazine a collet. So we put a collet on the main spindle number 3. Now we are going to clamp on the ID of the part that this was machined before. We're going to open only the top chuck. And now on the B-axis, we have 3 lathe tools. So we put the part in rotation, and we go to do the turning operation, the OD. Then we can reorient it, the B-axis, like you see now, we're going to do a chamfer. So this gives you a lot of flexibility. And again, it's a system that can be implemented also in a multi-center that is already delivered maybe 3 years before. So the multi-center really is flexible also on reconfiguration. And this is the second part. And then there is the unloading, marking, and the rest of the process. This is a similar application with aluminum automotive. In this case, there is an 8-meter long bar and unloading onto containers that customer gave us from his washing machine. So he doesn't want to know anything about it. He has the 8-meter bar and his washing machine container. So we take care about all the handling and machining between these 2 points. So there's the cutting, then taking the machine from the buffer into the load and unload station, 2 parts at a time. Then inside the process start with drilling, tapping, and all different. Here I'm going to skip some operation, just standard operation. Nothing special, but the special about this system is no human involved from the bar to the washing machine. So once we unload, we need also to do a marking operation on the parts. So the robot is going to deposit on the marking machine. And then there is a second robot that is taking from the marking into the wash container that the customer gave us. So like I said, from the bar to the wash container, no human involved between these 2 points. And we took care about also the handling. So there is a top conveyor with empty boxes, then a lower conveyor. Once the boxes are full, it just go down, go out directly into the washing machine. The last application, this again is automotive components, where we have a and B clamp. So every time the table index, you get one finish, you move the semi-finish and you load one rough operation. And we're going to skip the empty and show you. Okay, so load and load station and 3 working station. The video you see, we are not really machining because without the coolant we can't see anything. But just imagine that we are cutting real chips. So this is going to be still a rough. It's a rough area. The main problem here that this area has a very high tolerances over here and need to be concentric to the main bore, and even the radius, there is CPK values that are very tight. So we couldn't make a plunging operation because of the quality finish. It need to be single pointed, and the parts need to be put in rotation to keep the concentricity. So what we did, once we finished all the milling operation, drilling, at one point we change the tool, take again a collet similar to the application we saw before, and there is a tool on the turret over there. Now we're doing the turning operation, so in order to maintain this concentricity compared to the main bore. So like you see, all these applications are all applications from a standard multi-center machine. All the different fixtures are just studied like a kit. So how here you can really see how the multi-center, the standard machine, is already flexible. And by changing only fixture and program, of course, you can really adapt to many applications. So this gives you a big benefit. And together with the quick change from part to part, is a really changing way to process your medium low quantity and not work for stock but for the market.